Hello everyone, I am Shiv Prakash, Research Scholar, Department of Electrical Engineering, IIT BHU, Varanasi. Let's wait for some time. Wait for the student to join. Let's start the class. In this session, I covered Thevenin equivalent in Norton and star delta conversion. The first question is a practical current source provides a 20 kilowatt to a 50 ohm load. It means 50 ohm resistor is there and 20 kilowatt to a 200 ohm load. Then the maximum power that can be drawn from it. Sorry. It means they saying that a current source provide a power to a load which is vary. Sometimes it's 50 ohms, sometimes it will be 200 ohm. That's why the question want the maximum power transfer to the load in this condition. You know about the practical source and practical current source and practical voltage source. A practical voltage source is a voltage source and series resistor. This is a practical voltage source, and practical current source is a current source and have a parallel of a resistor. This is the practical current source. It's provide a 20 kilowatt to a 50 ohm of load. It means there is a load RL. Then this current is IL, and power for this load is IL square into RL. Means this is the source and this is the power. Same thing, can you convert this thing to a voltage source or Thevenin equivalent source? Thevenin equivalent is the simply RTH and VTH. For the conversion of Thevenin equivalent to this load, first of all you have to remove this load. Okay, suppose terminal A and B. Then find the resistor RTH. For the finding RTH, you have to disconnect all voltage source and current source. This is the current source. This will be open circuit. If there is a voltage source, the voltage source will be short circuit. Then what is the RTH? Is simply R. It means R is the RTH. Same thing if you want to find a VTH, means the open circuit voltage at this terminal is the VTH. This open circuit voltage is VTH. Current is I flowing through the resistor. If there is an open circuit, then current is not flowing through it, is 0. All the current is flowing through it only, and this will be positive, negative. What is the voltage of this resistor is I into R. Then simply you can say VTH is equal to I into R. RTH there, VTH is there. Simply you can write same circuit like that. This is the VTH, this is the RTH, and this is the RL, load resistor. The current is IL. Okay, take this circuit and solve like that. First thing is given as that current source, it means whole circuit is provided 20 kilowatt to a 50 ohm of resistor. It means this RL is 50 ohm and PL is equal to IL square into of RL. PL is 20 kilo, it means 20 10 to power of 3. IL we have to find square. RL is 50 ohm. If there is a 50 ohm, then what is the IL? In this condition, you can see IL is 20 into 1000 divided by a 50. L square is equal to, this 0 is cancelled out, 5. This will be a 400. Then IL is equal to 20 ampere in this condition. First condition, in case 1. If the IL is 20 ohm, then what can you retain this one VTH. In this case, VTH is equal to IL into RTH plus RL, sorry, I into RL. In this circuit, if you apply the KVL, then you get the VTH is equal to IL into RTH plus I into RL. IL is given, RL is also given. In the first case, what is this circuit? VTH is equal to IL is equal to 20 ampere. RTH you don't know. RTH IL is 20 ampere and IL in this case is 50 ohm. It means this circuit, this equation will be 20 RTH plus 1000. This will be equation number first. Then apply case 1. Okay, case 2. Same PL is equal to IL square into RL. In this case, this is also same 20 kilowatt. For IL is not there, 20 kilowatt to a 200 of ohm load. IL square into 200. Then what in this case, what is the IL square is equal to 20 into 1000 divided by of 200. This will be 100. Then what is the IL? IL is 10 ampere for this case. Case second, this is a VTH plus IL is 10 into RTH plus IL into RL. IL is 10, RL in this case is 200. Then 200 into of 10, this will be a 2000. This is two equation, VTH, RTH. Simply you can subtract equation 1 minus equation 2. VTH will be 0. This will be 20 RTH minus 10 RTH. It will be 10 RTH minus 1000 minus of 2000 is equal to minus of 1000. Then what is the RTH? RTH is equal to 100 of ohm. RTH is 100 ohm. Then put the value of RTH in any equation. We will get the value of VTH. 10 into 100 plus 200 in equation number second. Equation second. Then the VTH is equal to 3000 volt. RTH you get, VTH you get. And what is the circuit? This is a 3000 volt. This is the 100 ohm. This is the RL. And what is the maximum power? For maximum power, RL is equal to RS or here RTH. It will be a 100 ohm. And what is the power? IL square. PL is equal to IL square into of RL. What is the IL? V by R. It means VTH divided by F. This one 100 plus of 100. It is equal to 3000 divided by F 200. 15 ampere. Then power is equal to 15 square into RL is equal to 100 ohm. 225 into 100, then PL is equal to 22.5 kilowatt. Simply you can follow the statement when given in the question. Simply a practical current source provides a 20 kilowatt to a 50 ohm load. This is the current source. You can change this thing into VTH and RTH simply. Voltage source. Okay. Then it want the maximum power that can run from the this load resistor. Simply this one convert to the VTH and RTH and find a circuit VTH RTH in RL. This is the simple circuit. You can use the KVL. Two cases, two KVL and two equation. There is a two variable quantity VTH and RTH. You can find the value of VTH and RTH by using these two equations. Then after you can apply the maximum power theorem. RL is equal to RTH and the power is IL square into RL. Okay, let's go for the next question. Consider a circuit shown below. The voltage V is this voltage V across the 1 ohm resistor is. In this question asking the value of V. It means if you find the value of this current, suppose this current is I, then the V is equal to I into 1 equal to I. 1 ohm resistor, simply you can find the value of V. This type of simply you can take a node voltage V X and apply the KCL in this node. Simply incoming current is 5 ampere. You take 5 ampere is positive and 5 plus outgoing current Vx divided by F, this resistor Vx by 3 plus Vx by 6 plus Vx by another resistor 6 ohm resistor. This is the outgoing. Sorry, the all is the outgoing. Only this one is incoming. Incoming current in this one is positive. All outgoing current will be negative. Then this is the 15 ampere outgoing current. Okay. This is minus of Vx by 3. This is also Vx minus 6. Vx minus 6 is equal to 2 Vx minus 3. 6 divided by 2 is equal to 3 equal to 15. 5 minus 5 it will to minus of 10. Minus 10 is goes to the right side. It will be a 10. This will be 2 Vx by 3 is equal to minus of 10. If you multiply minus all things, then Vx is equal to minus of 15 volt. Then what is the current of I? I is equal to Vx divided by F3. This current is this voltage divided by this resistor. This 3 ohm resistor in the whole branch. Then this will be minus of 5 ampere. And what is the V? V is equal to I is same as minus of 5 volt because of there is just 1 ohm resistor. This is the 5 minus of 5 volt. So means it's a simple circuit. You can apply KCL in the circuit and you will get the answer. Voltage across the 1 ohm resistor. Sorry. Okay. Next question is there. Consider a circuit shown below. There is a three windings there. The branches. One branch have a resistor. Second branch have an inductor. Third one is the capacitor. At the steady state, the current through resistor is given by 15 cos t, and the voltage across the inductor is 2 sin t. Then the RMS value of the current through the capacitor is, not is the RMS current flowing through the capacitor. Okay, the resistor, inductor, capacitor. Three thing is there. Okay, suppose terminal. This is the A. This is B, C. Current is IR here. This current is IL. Instantaneous current is given, and this current is IC. Value is given as this one is 3 ohm, and this one is 2 Henry, and this one is 1 farad. The resistor current through the resistor is given. It means IR. IRT is given as 15 cos t. Okay. Then voltage is given across the inductor. It's 2 sin t. It means VL is given 2 sin t. And what is the current? No, VN is equal to L di by dt. Inductor current IL dt to 2 sin of t. This ILT is equal to L is 2 Henry. It means 2 divided by 2 sin t. You can multiply cross this one. Dt is here. Now apply integration both side. Simply apply the integration, and this will be IL into t is equal to 2 to cancel out. Sin t will be minus of cos t. IRT is here. ILT is here. Then you want to ICT. This is the node. Apply the KCL at the node. Then incoming current, sum of incoming current equal to outgoing current, or sum of all the individual current will have generic sum is 0. Then IR and IL is incoming current, IC is outgoing current. Then this will be IR into T plus IL into T minus of IC into T, because of the IC is the outgoing current. IR into T, IR is 15 cos T. This is the 15 cos of T. IL is equal to minus of cos T. This is the minus of ICT. Then what is the ICT? Is equal to 14 of cos T. Okay, but the question is asking the RMS value of the current. RMS value, it means magnitude divided by a root 2. This will be a 7 root 2 ampere. Okay, and this is the answer. Simply you can solve by using a KCL here. IR is a IR and IL is the incoming current and IC is the outgoing current. It means IR plus IL is equal to IC. IL simply given in the question and VL is given, then you can integrate VL to get the current across the inductor. Okay, yeah. This is a question about Thevenin equivalent resistor. Consider circuit shown in the figure below. The Thevenin equivalent resistance seen across the terminal A and B. Okay, I'll draw the circuit again. There's two terminal A and B. This is the 2 ohm resistor. It's minus plus of 3 I naught. This is 10 ohm resistor. This is I naught. This current source is 5 ampere. Suppose the question asking about the VTH and RTH, Thevenin equivalent voltage and Thevenin equivalent resistor. Now this circuit convert into the Thevenin equivalent circuit. Then how can find this thing? Okay. For the same question, I can write the RTH and VTH both. Suppose this is the suppose this is a 50 volt. This is a 65 volt. This is the 60 volt. And this is 65 volt. How can you find these two? Simply you know about the VTH equation or the RTH. For the finding the RTH, we have to find RTH equivalent of this one by removing the voltage source and current source. For the current source, this will be open circuit, and for the voltage source, that terminal will be short circuited. Then the circuit will be simply looks like this is 2 ohm minus plus of 3 I naught 10 ohm. This is the I naught. There are two things to find the RTH. VI method, it means you simply apply a voltage and a current across it and find the V by I. You will get the RTH. Or you can use the 1 volt is there. Simply 1 by I is equal to RTH. A voltage is 1 and this will be 1 by I. Okay, in place of 1 I simply use the V. We can say the I is current flowing through it. It means I naught is same as I, because of this current is same flowing through it. Then apply the KVL in this loop. Then what is this voltage? Minus of V plus 2I plus 3 I naught plus of 10 I naught is equal to 0. I naught is same as I, then replace the I naught, 2I plus 3I plus 10I is equal to 0. Then V is equal to 10 plus 3, 13 plus 2 is 15 I. Then V by I is equal to 15 ohm. This is the RTH. Okay. If there is a RTH, it means simply V by I is equal to RTH. Then for the VTH, Thevenin voltage, we have to find the open circuit voltage across it. The open circuit voltage. First one, draw the circuit again. A current source here. A resistor is here. This is the dependent source. 3 I naught. This is 2 ohm, 10 ohm. This is the I naught. Five ampere. This is the VTH. It means VOC, open circuit voltage. If this is the open circuit, suppose this is the open circuit, then what is the current flowing through it? If this is the circuit is open circuit, then current will be 0 ampere. It means current is not flowing through this branch. It means whole current is flowing through this only. It means all 5 ampere current flowing through this 10 ohm resistor. And simply you can say I naught is equal to 5, because of all current is flowing through it. Then VOC plus minus, apply the KVL again in this loop. This current is 0, it means this is a 0 voltage drop across 2 ohm resistor. No meaning of this resistor. Then this will be minus of VOC plus 3 I naught plus this will be 10 I naught, 0. VOC is equal to same, VTH is equal to 13 I naught. This will be 13 I naught is equal to 5. This is equal to 65 volt. It means VTH is equal to 65 volt. It means this circuit will be looks like that. If there is RL, then it will be RL, VTH and RTH. If there is RL, then this will be RL. RTH is equal to 15 ohm, VTH is equal to 65 volt. The same circuit in this circuit is looks like a voltage source and a resistor. This is 65 volt, this will be 15 ohm, VTH and RTH. Okay, this if anywhere if a dependent source is there, and we want to find the Thevenin equivalent or Norton equivalent, then you have to apply this type of method. For Thevenin equivalent, you have to open circuit of current source and short circuit voltage source for find the RTH. Then after apply the VI method. V by I is equal to RTH. We can find the RTH. Then after you have to find the open circuit voltage across this terminal. Then we will get the final VTH. Okay. But the same circuit you can use the another method also. Suppose don't remove the any source. This is a circuit 5 ampere 10 ohm. This is I naught minus of plus. This is 3 I naught. This is 2 ohm. Okay. Okay. Same circuit. Yeah. We have to find the RTH and VTH. Then don't remove the current source, voltage source. Simply apply a V and I, a voltage source and a current. To find this type of question, Thevenin or Norton's, simply apply V and I and don't remove the voltage and current. Then find the voltage V and I. Okay. In this condition, this current is I, this current is 5 ohm ampere. Then what is this current? I plus 5, because of this current is flowing through the here, this current is here, then both current is some here and going to the 10 ohm resistor. Okay. Then simply apply the KVL. Then we can say I naught is equal to I plus 5, because of this current is flowing I plus 5 here. Then apply KVL in this loop 1. Same thing, this is a minus, this is plus. Apply from here, minus of V plus 2I plus this is only 3 I naught plus this is I plus 5, or you can say I naught 10 into I naught, this is I naught equal to 0. Then B is equal to 2I plus 13 I naught. You can replace I naught by I plus 5. 2I plus I plus 5. B is equal to, so 13 I plus 5. 2I plus 13I plus 65. B is equal to 15I plus 65. We have to simply apply V and I and find this V and I equation like that. In this case, this is the RTH, your RTH, and this is your VTH. We'll get the both in single equation, VTH and RTH. We simply apply the V and I and we'll find the voltage like that. I plus something. In this case, here is the RTH and here is anything is there. This is the VTH. You can match this thing also from this one. This equation RTH is 15 ohm. Simply this is a 15 ohm and VTH is 65 volt. This is a 65 volt. No need to apply the find the separate VTH and RTH. If there is a dependent source, Then simply apply VI method, and VI simply find the V is equal to something I plus something. I multiplication of I is RTH, and remaining thing is VTH. Okay. Same thing. If you want to find the Nortons, if you get the VTH and RTH Thevenin equivalent, suppose this is the Thevenin equivalent, VTH and RTH. Same thing, you can convert this one in Nortons also, because this is voltage source, Norton is the current source. I and Rn. A current source, you can convert a current source into voltage source and voltage source into current source. Both conversion you can do. In this case, In is equal to VTH by RTH, and Rn is same as the RTH. You can convert Norton to Thevenin, Thevenin to Norton. Apply this thing. Okay. Next question, in the circuit shown below, the maximum power transfer to the load RL, if it will be. Is asking the value of RL for maximum power P max. Is a dependent source is there. Again, if there is a dependent source and asking about the value of RL or the maximum power transfer, simply you have to find the RTH. Then you know RTH is equal to the RL for the maximum power transfer. Okay. This whole circuit, how can you find the VTH and RTH? Simply remove the that resistor, remove this resistor from remaining circuit. This is 2 I1. This is the 14 ohm, 80 ohm. This is a 100 volt. This is the I1. For dependent source circuit, to find the RTH VTH, simply apply VI method. This is the V and current flowing through it I. You have to find V something I plus something, and this is the RTH and this is the VTH. Okay. This is the voltage, common voltage. This is sorted, it means same voltage is here, V. Then apply KCL at node V. Then incoming current is 2I1. Incoming current take a positive, then 2I1 plus outgoing current, take out is outgoing current. Incoming current is another, and current is I, plus this is a minus outgoing current is V by 40 minus this I1 is equal to 0. I write same thing here, minus plus of I1 plus I is equal to 0. What is the I1? This current. For I1, V, this voltage minus of this voltage, V minus of 100 divided by of this resistance 80 is equal to I1. Put the value of I1 here. This will be V by 40 plus V minus of 100 divided by of 80, I is equal to 0. LCM of this is 80, 40 to the 80, it's minus of 2V plus of V minus of 100 plus of 80, I is equal to 0. This is minus of V minus of 100 plus of 80, I is equal to 0. What is the voltage? V. V is equal to 80 I minus of 100. It means this is the RTH, this is the VTH. Minus of 100 means the sign of the voltage is, this voltage is reverse. And you know, for the maximum power, for P maximum, this circuit VTH RTH, it means this circuit will be looks like that. VTH, RTH and RL. Then you know about P max. For P max, RL should be equal to RTH. RTH is given here. Then RL is equal to 80 ohm. Same as the RTL for maximum power transfer. Okay. Equation of I1. This current, I1 is this current. And this current, it means this voltage minus of this voltage divided by a resistor. Same thing like that. If there is no voltage source is there, that's why V by 40 is the current flowing through it. Because of this voltage is V. That's why this is the V minus of 100 volt divided by 80 is equal to I1. Okay, same thing you can apply everywhere is there is a dependent source, then you can apply V and I to find the VTH RTH. If you want to find the Norton's equivalent, simply you can convert Thevenin equivalent into Norton's equivalent. RTH is same as the RN, and IN, Norton's current, is equal to VTH divided by of RTH. Sorry. Okay. The next question, the equivalent resistance seen across the terminal A, B in the given figures below. All are connected together. We have to find the equivalent resistor. This type of question you can solve by using a star delta conversion. Okay. So there is two things. This is a star connection, terminal X, terminal Y, and terminal Z. This resistor is RX, RY, RZ. Same thing for the delta conversion. This terminal is X, same this terminal Y, this terminal is Z. XY is R1, YZ, R2, ZX, R3. Suppose if you apply the voltage across these two terminal, then this is the open circuit. This is the open circuit. It means the whole current passing through it only. This thing. Then what is the R X Y? It means total resistance between R X and Y is RX plus RY. RX plus RY. Same thing. If you want to find apply the voltage source here and find the equivalent resistor is here. This is the open circuit. Current flowing through 0. No meaning of this resistor. Then equivalent resistors of this one is R Y Z is equal to RY plus RZ. Same thing here also. RZX is equal to RZ plus RX. Okay. Same thing suppose you can do for the delta. You apply the terminal, this terminal RY, suppose this terminal XY, then what happens? These two are connected in series. These two are connected in series with parallel of R1. Then you can say RXY is equal to R1 parallel with R2 plus R3. R1 parallel with R2 plus R3. And this will be equal to R1 R2 multiplication of both R1 R3 divided by of summation of all R1 R2 plus R3. If you find the parallel combination of these two, same thing you can apply from here also. These two in series with parallel of R2, RYZ is equal to R2 parallel of R1 plus R3. This will be R1 R2 plus R2 R3 divided by of R1 plus R2 plus of R3. Rzx, Rzx simply here. Then these two is series with parallel of R3, R3 parallel of R1 plus R2. This will be R1 R3 plus R2 R3 divided by of R1 plus R2 plus of R3. In this condition, you can say the Rxy and Rxy both are same in both condition. Terminal across this terminal, if you apply the same voltage, then same current is flowing through it, and that's why the Rxy and Rxy for the both condition it will be same. Rxy star, Rxy delta. Then this will be Rx plus Ry is equal to R1 R2 plus R1 R3 divided by of R1 plus R2 plus R3. Equation number first. Same thing you can do for Ry, Rz, for Ryz. This will be R1 R2 plus R2 R3 equation number third. Same thing for Rz plus Rx. This will be R1 R3 plus R2 R3 divided by R1 plus R2 plus R3. To find the Rx in terms of, it means a delta conversion in terms of star conversion in terms of delta resistance. Then equation 1, suppose you can subtract to 1 minus of 2, then y will be cancelled out, Rx minus of Rz is here is equal to, then R1 R3 R1 R2 R1 R2 in both condition, R1 R2 is cancelled out, R1 R3 is there, R1 R3 minus of R2 R3 only. Denominator both are same, that's why this is the same. Suppose question number 4, then simply question 4 can add the question number 3, then z will be cancelled out, Rx will be 2 of Rx, then R2 R3 plus minus cancel out, R1 R3 is both, that's why this will be 2 R1 R3 R1 plus R2, then 2 will be cancel out, you can say Rx is equal to R1 R3 divided by of R1 plus R2 plus R3. Value of Rx is there. Same thing you can apply for Ry. Sorry, for the Ry, this will be a R1 R2 divided by R1 plus R2 plus R3 for Rz Same thing, R2 R3 can apply for us all. This is a delta to star conversion. It means if there is delta like that, x, y, z, this is the R1, R2 and R3. You want to convert this thing in the star, then the star will be like that. Rx, Ry, Rz. If you want to find the Rx, that means Rx is connected between R3 and R1. Then multiplication of these two, R1 and R3. Multiplication of these two, R1 and R3 divided by a total sum. Same thing if you want to find Ry, then Ry connected to the between R1 and R2, then these two multiplication of these two register R1 R2, then sum of the all. Same thing if you want to go for the Rz, it means this is connected between R2 and R3, then multiplication of R2 R3 divided by of all, sum of all resistances. Okay, this is the conversion between delta to star. This is delta to star conversion. Suppose R1 plus R2 plus R1 is equal to R2 is equal to R3 is equal to suppose R. Then in this case, what is the Rx? Rx is equal to R square divided by of 3R. It means R by 3. What the Ry? Same, R square divided by of 3R, R by 3. Simply one third. If all the resistances are same, then one third is resistance is the star with respect to the delta. The same thing if you want to convert star to delta, then this is the delta resistances Rxy, Ryz, Rzx. Okay. Find the star delta star to delta conversion. Start from here. Multiplication of these two, Rx into Ry plus Ry into Rz plus Rz into Rx. Multiply these two, then like that. We multiply Rx into Ry, that means R1 square R2 R3 divided by of R1 R2 R3 whole square. This will be R1 square into R2 R3. This will be R1 square into R2 R3 divided by f R1 plus R2 plus R3 square, these two, plus for RYZ RY RZ multiplication of these two, it means R2 square R1 R3 R2 square R1 R3 divided by a same R1 plus R2 plus R3, because of all denominator is same. If RZ and RX multiplication, RZ and RX, it means there is a R3 is common. Then R3 square R1 R2 divided by f R1 plus R2 plus R3 square. This whole denominator is same. You can take a common R1 plus R2 plus R3 whole square. This will be a R1 square into R2 R3 plus R2 square into R1 R3 plus R3 square into R1 R2. Rx Ry plus Ry Rz plus Rz Rx. Then divided by Rx here in the whole equation. Suppose this equation is 4. Suppose this equation is fifth. Rx in equation fifth. Then Rx will be cancelled out here. Only Ry and Rz is there. Ry plus Rz plus Ry Rz divided by Rx is there. This will be same thing. What is the Rx? Rx is R1 R3 divided by f R1 R2 and R3. Okay. Then in this case you can common R1 here, R1 in all the equation, R2 in the all sum, R3 in the all. Then you can common R1 R2 R3 here. The remaining is here is R1, here is R2 and here is R3. Divide by of Rx R1 R2 R3 square. One R1 R2 R1 plus R2 plus R3 is cancelled out here. Denominator also. Okay. This is the one cancel out. Only there is only. This will be Ry Rz Ry Rz divided by f Rx is equal to R1 R2 R3 divided by f Rx to R1 plus R2 plus R3. Put the value of Rx here in this equation. What is the value of Rx? Rx is R1 R2 divided by f R1 plus R2 plus R3. This will be R1 R2 R3. Value of this one is equal to R1 into R3, Rx into, sorry, divide by f, R1 plus R2 plus half R3 into this R1 plus R2 plus R3. You can see this one cancel out, R1 R3 is cancel out here also, only R2 is there. When delta to star conversion, R2 is equal to Ry plus Rz plus Ry Rz divided by f Rx is there only. Same thing you can say for the R3, simply reverse this one order. Rz plus Rx plus Rz Rx divided by f remaining Ry R1 Ry, sorry, Rx plus Ry plus Rx Ry divided by f Rz. It means if there is a star connection, x, y, z, this is the Rx, Ry, Rz. If you want to convert this thing in delta, okay, this is R1, R2, R1 is between R and y, x and y, R2 is between y and z, and R3 between z and x. In this condition, for find the value of R1, you have to add these two, Rx and plus Ry plus multiplication of this and divide by of another Rz. Same thing if we want to find the R2, then sum of these two, Ry Rz, Ry Rz plus multiplication of these two divide by of another. Same thing for the R3, then sum of these two, Rz Rx plus multiplication of these two and divide by another. Suppose in star, for Rx is equal to Ry is equal to Rz is equal to R, then what is the value of R1, R2 and R3? In this case, R1 is R plus R plus R square divided by R. It means R1 is 3R, R2 is equal to also 3R, R3 is equal to also 3R. It means if you want to convert the star to delta, then the star is it will be triple to the star, and if you want to convert the star delta into star, then you have to divide by 3. There is a same resistance is there.
So for exam purpose, we have to remember these formulas for these conversions.
No, you simply learn this formula only. Oh,
Yes.
you need this formula only to convert the formula. I derived all of thing by understanding only. Simply you
Yes, sir.
understand this formula. If you want to convert star to delta, then check this is star connection. You want to find this register, then simply add these two and plus multiply these two and divide by another. then we'll get the answer. Same thing if we want to convert the delta into star, then del this register is connected between these two, then multiplication of these two divided by all sum of registers. We'll get the star value. Only formula we want to learn, but okay. Let's complete this question. So now I remain these two terminal is there in a register. This is a 2 ohm register. This is 2 ohm. This is 6 ohm. This is also 6 ohm. This is 6 ohm. This is 12 ohm. Okay. Then we have to find the register across the terminal A and B. This is the delta connection. This is also delta connection in same resistances. Then we can convert these two into star conversion. These three resistances also convert into star. Same resistance, if you want to convert delta to star, then you have to divide by 3. Then 12 divided by 3 is 4 ohm. This is also 4 ohm. This is also 4 ohm. And divided by 3 here, it means this will be 2 ohm. This will be 2 ohm. This will be 2 ohm. Simply I written again. I write this one. This looks like that 2 ohm, this one 2 ohm. This 2 is there, 2 ohm, this 2 ohm, this 2 ohm remaining. This is 4 ohm, 4 ohm. This is the 4 ohm, and middle one is the 4 ohm into 2 and 2 ohm. 4 ohm. Okay. In this case, you can see these two are in series, these two are in series, and these two are in series. Then solve this one. I write here. On the same thing written like that. This is the 4 ohm. This is 4 ohm. This is 4 ohm. This two combination is 4 ohm. Again, this combination is 6 ohm. Okay. There is another star. You can convert this thing in delta. like that. What is this resistance? This resistance is connected between this 4 ohm and 6 ohm terminal. Then start to delta conversion. Then sum of these two, 4 plus 6 plus multiplication of these two, 24 divided by up, another is 4. This will be 4 plus 6, 10. This will be 8. 6. This will be total 16 ohm. Okay. This is the 16 ohm. What happening here? In this case, this is connected between 6 and 4. This is also 16 ohm because of this is also connected 6 and 4. 4 plus 6 plus 24 by 4 is equal to 16. Then what is this one? This is connected between 4, 4, then 4 plus 4 plus multiplication of these two is 16 divided by another one 6. This will be 4, 4, 8 and this will be a 2.67. That's why this will be a 10.67 ohm. Then these two are connected in series. This is a single resistor and this is connected in series. Terminal A, B. This is a 10.67 ohm. Then these two are in parallel combination, 16 and 4. 16 and 4, this will be 64 divided by 20. This will be 3.2 ohm. This is also same 3.2 ohm. Then what is the RAB? RAB is equal to 10.67 parallel with a 6.4. 10.67 multiplication of 6.4 divided by sum of these two, 10.67 plus 6.4. You can calculate this one. This will be I think 4 ohm. Okay. Simply you can do the star delta conversion. But there is a trick. If you see this thing after conversion of first case, if you care about this one, then this circuit can you this circuit written as this is 4 ohm, 4 ohm, it's okay. A and B. Then these two is sum. Then this is also 4 ohm and these two are also same. This also, that's why this also 4 ohm and middle ohm is sum of these two is 6 ohm. In this case, we know about a Wheatstone bridge. Multiplication of these two is equal to multiplication of these two, and this will be open circuit. This 448 ohm resistor connected with parallel with a 448 ohm. It means 8 parallel with 8 is equal to 4 ohm. Final answer. No need to do again this thing. But if you not understand, then simply start with a star delta conversion. That's after simply convert this thing to find the final answer. Sorry. It's okay for all. The next question, consider the circuit shown in the figure below. The Norton's equivalent seen across the terminal A and B. For the Norton's, you know about find the open circuit here and find the resistor. For Rn, uh, disconnect the sources. Then but this is a voltage source. Voltage source will be short circuited. This two terminal is the Rn. It means this is connected with 40 ohm and 60 ohm. Rn simply parallel with 60. 40 into 60 divided by a sum of these two, it will be 100. Then Rn is equal to 24 ohm. For the In, we have to short circuit this one. This is 40 volt, this is 120 volt, 40 ohm, this is 60 ohm. You have to find the current in this branch. Sorry, In. This is short circuit, it means the whole current flowing through it, this one, this current flowing through this one. Then you can say simply In is equal to current flowing through this for this source is 120 by 40 plus for this source is equal to 40 by 60. Then this will be 3, this will be 0.67 is equal to 3.67 ampere. Okay, In is equal to 3.67 and Rn is equal to 24. This option is correct. Okay. The next question is, consider the circuit shown in the figure below. The total power delivered by the dependent source. This is the only dependent source. We have to find the total power delivered from this. Power delivered, it means current flowing through it. Is this one? We have to find the current and voltage. It draw the bigger circuit. This is 1 ohm. This is 2 ampere current. 10 volt over V naught. This is a 4 ohm resistor. V naught is given as at 1 ohm. Then when find this one, let the current flowing through it is I. Okay. 2 ampere current is flowing through this here. Then remaining current is flowing through this only. Then I minus 2 is there. And you know about this is the voltage. So voltage is given across the 1 ohm resistor. Then what is the current? V naught divided by 1 is the current is same as V naught divided by ohm 1 is same as the I minus up to, you can say V output is equal to I minus 2. Equation number first. Okay. Now you can apply a KVL any loop in this loop suppose. Then start from here minus of 4 V naught plus of 4 I plus of this V naught is equal to I minus 2 plus of I minus 2 current into ohm resistor plus 10 volt voltage source minus of 4 V naught plus 4 I plus this I is 5 I plus 10 minus of 2 is equal to 8. Okay, you can put the value of V naught here also. Then what is this one? Minus of 4 V naught is I minus 2 plus 5 I plus 8 is equal to 0. Minus of 4I plus 5I is equal to I minus of 4 minus 2 is equal to 8 plus 8 is equal to 16. I is equal to minus of 16 ampere. Then what is the voltage? Minus of 16 minus of 2 is equal to minus of 18. Power delivered by this one is the voltage source is 4 V naught. Then 4 V naught into I, 4 V naught is equal to minus of 18, I is equal to minus of 16. We have to multiply up these 3, 4 into 18 into 16, it will be 1152 watt.
Sir,
Yes.
sir, here minus current is entering from minus, no, sir?
Yes, both are reverse. Na? Voltage and current both are reverse in this condition. Voltage also reverse.
So we can directly tell like it's power delivering since entering minus.
No, no, this is not entering minus. Na? This voltage source is also reverse because of this na minus 18. It means this is the positive, this is the negative of 18 volt and current is also reverse. Then current is like that, na? I, or you can say this is the 16 ampere. Then current enters negative, na? It means leaving from positive. Then this is the positive and current leaving from positive and current flowing like that. That's why this is the power delivered in this condition because the voltage and current both are reverse.
Yes, sir. Now I understood, sir.
Okay. If any one is reverse, suppose this is the positive and current is negative, then this is the absorb the power, display the power, not the deliver the power because of current is enters from positive. The so if the voltage source is same, it means this is a 18 volt and the current is reverse direction. Then current is flowing through it. It means current enters from positive. Then this is behaving like a sink, not a source. In this condition, this is absorb the power or dissipate the power. but here both are negative. Then both are negative, both sign will be changed. I, and this will be a 4 V naught. This is V naught. Okay.
Yes, sir.
Next question. For the circuit shown in below figure, the value of R, this R asking such that the maximum power delivered to the load is 5 milliwatt. We want to value of R to power delivered to this load is maximum power is 5 milliwatt. In such cases, simply find the VTH and RTH. For RTH, you know about the RTH. Simply remove the voltage source will be short circuited and all three resistors are connected in series. Sorry, in parallel. This is R, this is R, this is R. R3 are connected in parallel, then the RTH it will be R by 3. For VTH, we have to open this load resistor. For simplify, I can write like that. We have to find this voltage. VOC is equal to VTH. 1 volt, 2 volt, 3 volt. This will be R, R, and R. This voltage is VTH. This is a common voltage. Then this voltage is also VTH. Apply KCL. VTH minus of 1 volt divided by of R plus VTH minus of 2 volt divided by of R plus VTH minus of 3 volt divided by of R is equal to 0. Then there are 3 VTH minus 1, 2, 3 is equal to 6, 0. Then VTH is equal to 2 volt. Okay, RTH is R by 3, VTH is 2 volt. Then you can rewrite the circuit. Thevenin equivalent. VTH and RTH. This is RL. What is the maximum power transfer? For P max, RL is equal to RTH is equal to R by 3 for P max. And what is the power is I is equal to V by total R, RTH plus RL. Both are the same, R by 3. Then V divided by 2R by 3 is equal to 3 by 2 into V by R. In case of V is VTH here. Okay. Then what is the power? Power is equal to I square into RL. I is 3 by 2 into VTH by R square into R. RL is same as R by 3 because of RTH. This power is given as 5 milliwatt. 10 to power minus of 3. This will be 9 by 4 into VTH. VTH is 2. 2 square is equal to 4 divided by of R square into R by 3 is equal to 5 into 10 to power of minus of 3. R cancel out, 1 R, 4 cancel out. This will be 3 by R is equal to 5 into 10 to power of minus of 3, and value of R is equal to 3 divided by of 5 into 10 to power of minus of 3, 3000 divided by 5 is equal to 600 ohm. R is equal to 600 ohm. A 600 of ohm required for the power transfer to RL is equal to 5 milliwatt. Okay, the next and last question is, consider circuit shown in the figure below. The value of resistor R such that the energy stored in the inductor is 16 joule. This is a DC source. It means this is a short circuited in DC source. We have to find this current, the value of R. Then what is the current? You know about the energy of L I square or the inductor. This is given as 16 joule. L is given 8. I square is equal to 32. I square is equal to 4. Then I is equal to 2. This current I is equal to 2 ampere. Okay. Then this circuit, it looks like that after the inductor short circuited. Four ampere. This is a 15 ohm. This is R. This current is known as I. Then current divider, you can apply current divider rule. I is equal to total current 4 ampere into opposite resistance is 15 ohm. 50 ohm divided by of total resistance is R plus 50, and this is calculated as 2. Then 2 cancel out. This will be 100 divided by R plus 50. Then R is equal to 15 ohm. Okay. R is equal to 15 ohm for this case. So there is another question also here. Four resistors of equal value when connected in parallel across a supply dissipated at 150 watt. If the same resistor are now connected in series across the same supply, then what is the power? It means there is a voltage source. Four resistors are connected in parallel. Same value. It means R, R, R. What is equivalent resistor? R by 4. What is the power? Equal to V square by R equal to 4 V square by R is equal to 150 watt. And what is the V square by R? 150 divided by 4 is equal to 37.5. Suppose question number first. Same thing connected in series. R, R, R. What is the equivalent for this condition? R equivalent is equal to 4R. Then power in this case is V square divided by R. 4R. We know 1 by 4 V square by R is here 37.5. Then in this case power dissipation is equal to 37.5 divided by 4 is equal to 9.375 watt. Okay, everyone. I want to stop here. There is a question related to the super node. I will discuss in next session. And next session is the same on the Tuesday 7 to 9 p.m. like before. Okay, it means next Tuesday I will discuss about the super node and other questions. Okay, thank you to all.